Center for Innovative Sintered Products, CISP, located at PennState University, count with many persons working in different research projects. The center is a true integration between universities, industry, government agencies, professionals, and community. CISP represents a reference center of research in this area, training and receiving different researchers from different parts of the world. The CISP director is Professor Randall Germann, and in name of the direction of CISP, I would like to invite you to know our facility. Now we're going to start our visit to the center, showing you first the torque rheometer. Here you have one important step to prepare the mixture of powders, polymers, and other substances that are going to compound the feedstock.
The torque rheometer is used to determine the maximum solid fraction and mixture stability. It is composed of two counter-rotating mixing elements attached to a drive motor. The extruder sensors of the rheomix range enable the determination of rheological variables as well as the examination of processing characteristics and the production of feedstock for further analysis. The equipment is computer interfaced to control all rheological functions.
Another important step is the mixing process.
Here you can see the blender, which is used to initially mix powders and binder components together. After the materials are mixed, it is passed through a high shear rate double tween mixer. This kind of operation guarantees good homogeneity of the final feedstock.
Capillary rheometer, an important equipment to monitorize the viscosity of the feedstock.
High-pressure capillary rheometers use a heated measuring chamber to melt the feedstock. After preheating and melting, the test sample is pressed with the defined flow speed through a capillary nozzle. The equipment is computer interfaced to control all rheological functions, and the data can characterize the fluid type as Newtonian or non-Newtonian.
Now let's go to see the injection molding process. Another important step in power injection molding is the debinding process. After molding, the binder is removed from the compact by a process termed debinding. In this case, we have a solvent debinding that consists to immerse the compact in a solvent that dissolves one of the binder constituents, leaving behind the polymer that hold together the particles. Now we are in the sintering area. Take care! Don't touch anything directly.
Hydrogen-nitrogen retort furnaces with Inconel retorts used for debinding before sintering. Max temperature 1200 degrees Celsius. Some bronze parts used, or debound bronze parts with aluminous headers used to separate the parts during debinding and pre-sintering in the retort furnaces. A large retort furnace used for debinding large quantities of parts. Again, the flames represent hydrogen burning off the furnaces. This is a Seiko Woolwork 2200 degree graphite vacuum furnace with a 1 cubic foot hot zone. Also available nitrogen and argon partial pressures. This Scott large retort furnace with burn-off stack, 900 degrees Celsius with Inconel retort. This is the CM pusher furnace used for 1700 degree sintering with 5 hot zones. These are CM horizontal and vertical tube furnaces used for sintering in hydrogen-nitrogen atmospheres. max temperature 1500 degrees Celsius. You can see the burn off flames on the ends of the furnaces burning off the hydrogen. Alumina tubes inside of these furnaces. Hydrogen pusher furnace again with a zone for this is the MRF vacuum furnace with a moly hot zone, tungsten heating elements, 1700 degree maximum capability. This is the KYK continuous graphite sintering furnace with graphite belt, argon nitrogen atmosphere with 2200 degrees Celsius maximum temperature. 4 hot zones inside of this furnace. This is a 60-ton Gasberry hydraulic compaction, 30-ton Gasberry mechanical.
Traditional powder metallurgy process.
This is a 60-ton Gasberry hydraulic compaction, 30-ton Gasberry mechanical compaction press, single level, die set or die plate press. It's not a die set press though.
Creating physical models using wrapped prototyping. Metal powder are used to produce green bodies by selective laser sintering and subsequently sinter densified in a furnace. This involves melting an admixed polymer with a laser to bond the metal powder together. The laser scanning pattern is determined by the computer-aided design data. The object is built by the incremental layers of powder and bounding the appropriate areas with the laser. Here you can see some processed parts. Now we are in the polishing and design laboratory.
This is the metallography lab. There are 3 manual grinding wheels, a hot mounting press, an auto polisher, as well as various cutting saws to section off samples.
The CISP lab is the prototype for developing sintered bronze casting for artist applications. These lion head sculptures have been prepared for mold making and slurry casting. The smaller art objects shown have been cast in this new fashion.
Now we have a view of the powder characterization laboratory.
This lab is where metal powders are first evaluated. Gas picnometry on the right and envelope density on the left are equipment shown on the first lab bench. Next is equipment which gives the particle size distribution of a given powder. It can analyze powders dispersed in a liquid or powders dispersed in air, and runs on the principle of laser scattering. Other equipment shown includes rifflers, tap density, surface area, and balances for weighing. Nanopowders are characterized using Brownian motion. Other methods include electrical zone sensing, laser scattering, which can use ultrasonics to help break up powder agglomerates, and the time of flight particle sizing method. This is sedimentation particle sizing equipment using the Stokes law principle. Open and interconnected pores inside powders and parts are measured using mercury porosimeters. And an inverted stage microscope with attached digital camera is useful for capturing images of samples prepared metallographically. This is the scanning electron microscope. I have a sample of powder inside the SEM here, and what I've done is to use the X and Y controls to move to where I would like to view the powder. I have on screen here a magnification at 3000x, and it's showing the structure of my powder. What I want to do is take a picture of this powder so I can save the picture for my project, or I might want to include it in a report. Over here is a picture that I just captured and saved for future reference.
Laboratory of Thermoanalysis.
Seen here is the dilatometer, which can measure shrinkage during sintering, a DTA-TGA unit, which can determine binder burnout temperature and the liquid as solidus of a material, an air furnace, and a differential scanning calorimeter unit, which can also perform DTA-TGA measurements in nitrogen, argon, or hydrogen atmospheres. This is the multiple axial in situ monitoring laser dilatometer. It is used in CISP at the PennState University for solvent debinding studies.
Laboratory of Mechanical Tests.
This is a fatigue tester. The arm of the Charpy impact tester remains swinging after completion of a test. This is the tensile tester, with samples awaiting testing. This is a micro-hardness tester, and it is used to test hardness of different phases in different materials. The Vickers indenter is being used here. The operator is measuring the size of the indent and receiving a final hardness result of 671 hardness Vickers.
Software simulation researches. The researchers at CISP try to utilize the CASE software not only to development successfully the parts, but also to reduce the developing time and cost for high-precision pin parts. The CASE software has the several functions such as geometry modeling, treatment of input data, simulation of each step, and display of results. Outreach programs.
CISP outreach and education key objectives are to promote science and engineering careers, provide undergraduate involvement in research, heighten industrial perspectives, disseminate research findings, and increase public awareness. These are achieved through short courses, workshops, seminars, educational programs, collaborations, and CISP testing and services.
Metal injection molding offers two major advantages over conventional powder metallurgy: three-dimensional design flexibility and high density. Some of the applications of pin are brackets for straightening teeth, medical applications as surgical tools, instrumentation, small gears for electrical hand tools and toothbrushes, cameras case, sculptures, weapons, handguns components, electronic packaging, hand tools, hermetic packaging, date storage, automotives part, microwave components, accessories, and drill parts. We are glad to receive you here, and we hope that you enjoyed the visit to CISP.